Right, then I get just straight up into the topic. So this is just a short introduction to DataLad. By having a little bit less time than we planned, we make it a very short introduction because essentially lots of the things I'm going to present are also available online, and I show you where essentially this is. I also give you some examples of Jülich activities that we already have DataLad actually here in practice working. So just to give you a feeling where we are in the set of the long technologies around here. So you see DataLad, but also was presented by Petur Helgi, is basically within the heart here of all what we plan. So it has relationships to containers. It has obviously perspective. Then it's really interesting to see that has some analogy in the world of coding. So we're talking about essentially saying versioning of coding. And some of you are familiar with Git structures, where this is really an idea of doing data management, but on a way of how you did source code before. So a versioning system with Git and Git.nix is actually built below this system. It enables you really to have an interesting data management, which tracks the history, what you did on the data, how you expose data, how you essentially work with data. Here are some examples, right? So of course you can create new data sets, which are not only neuroscience data sets. You can use it. It's very much a tool for every domain. You can create new data sets to pull it, basically, or push it into a repository. As a normal source code repository and versioning control system, you get updates if someone else has worked on the data sets. You can clone the repository basically to your workstation or your local environment. Or of course, the other way around, once you have done some work, you can either do a sibling or basically also do and essentially push it back to the repository so that everybody can see it. With this, of course, every step what you do there is tracked, right? So that other people can realize what was happening with the data in between the time. And now what it really enables you is that you essentially can now do software coding, Python scripts, with a deep learning script, for instance, but you basically alongside with it have now also much more a fine-grained idea about control of the data set. So kind of life cycle if you want. Also, if you want to think about how you use it, really, there are different ways of using it. One is, of course, very straightforward, especially when you think about the supercomputing environments we want to address here and that some of you already use. Basically, you can use DataLab here in the typical Python script by the import statement here. It has a very nice API, but of course, you can also use it then on the command line. In generally, I would just output out because I have less time today. You will see essentially here the handbook.datalad.org. If in doubt, I would have shown that now, but I will do this now. But if you go there, you see lots of details where DataLad can be used. It's a very nice resource for having introduction, of having basics, and there are also a couple of use cases. So in a way, when you think about now how that looks like, you would see that you have the several, let's say, footprints of the date. You see who is working on the data here. And then, of course, you have some typical kind of comments, what was happening to the data set and so forth. And the data is, of course, something where when you here see of the left-hand side structure, it's a big question mark. What means data? Could be raw data, could be already part of the analysis data. You see here essentially an example of a data structure and how it affects the data-led idea, but it's not really fixed. So essentially it's very open to a modular structure that you define on your own. And you can basically see then that this is very nice when you have maybe a few examples looked at. As I said, also here, the handbook has a couple of examples where, for instance, reproducible paper is often quoted, which shows, again, basically a problem from all of us, if you really want to augment it then with things like provenance, which brings me then also to the next slide already quite fast. You see already here some examples where we are using this in Jülich. This is the INM7 Institute, and here the left hand of the slides is really the courtesy here of Kaustup and his team, using it for basically predictive associations and then also machine learning models and let's say more coding, but alongside with it, really in DataLad having everything together, which makes it really, let's say, interesting, comprehensive data collection and management that is actually done there. I should also quote here Michael Hanke, who is also very active in this team, and Jürgen Duckert. And there's actually also a YouTube link that I will show later. But what I also wanted to point out with this slide is it goes much more far than individual groups would go and how we use it. So you see here on the right-hand side, maybe the different properties of data. And this means with all the different roles that we have here in Jülich, a different institute, maybe the Jülich Supercomputing Center that runs the supercomputers is a little bit different than the Einem, research institutes, where we are thinking much more about long-term preservation of data and so on. So what happens in the long term? And you can really nicely, let's say, as you see below here, also link it to the whole software environment that you have, where containers play a big role, for instance, what you have already heard from Petur, but also making reproducibility really more realistic, not only in terms of code, now also basically having the data versions and the correct data alongside it. And yeah, looking at the time, I think I get more and more to want to finish a bit earlier. But if you go now around the multimodal data sources we have in the human brain and in the different groups that we have for different analysis, there it becomes really a requirement to think more about data. And when you think that we have lots of interesting infrastructure that was Petur also presenting, this is still the question how that really will work together with, let's say, also technologies which advance very quickly, like our JUBIL system you see here on the bottom, right? This is #1 in Europe right now. Just to give you in the booster module, maybe one example, it has about 4,000 GPUs. So it's a model which basically also has a very past, where we had starting from a couple of cores, and now we are at the cutting edge of having lots of different GPUs. And essentially, this reflects a lot of data questions, where also then DataLad will be linked into different aspects of the file system versus also the access when we use it during computation. And this is just basically the booster that you see here in the Jülich system. We have a cluster module. We plan to do more work, and some of my groups actually start already to explore the quantum module more with the D-Wave system. So you see essentially lots of innovation happening, and having a good track of data with DataLad is certainly a very good way of porting it more easier between the different, let's say, generations, I would say, of the HPC that we also engage in HIBALL. Just to do it not too long, we will see a much more comprehensive, let's say, details from Tristan and the other team, basically from Canada, basically after me. Just to think about that DataLad is not just a little bit of data that you put in kind of a Git. I think it helps you with lots of questions along the way and to make really successful data management, starting from preservation, where you think about unique identifiers, up to making it accessible, and the kind of fair ideas that are there in the Open Commission. I guess Canada is something very similar. I'm making it basically findable, accessible, interoperable, and reproducible or reusable, really, the data. This is really a helpful tool. So if you want to learn more, of course, stay online, because we bring you more in this tutorial, but with a particular detail on neuroscience, of course. If you want to know more generally, you will have also here a very nice video resource. In general, DataLad has a YouTube channel, which I would encourage you to look at. But this one here from Michael Hanke is also quite nice, because he really points out the connections to the successful data management with, preservation combined with analysis. So this is a good resource. And at the end, we have really some resources where you can look it up. As I said, again, maybe as a kind of summary, if you want, the DataLad handbook is something which has lots of basics, has lots of introduction. That's what I want to recommend you really here to look at if you're seriously interested adopting it. And there's lots of interesting aspects that we basically can, really not all in the time frame of the short tutorial show here, but there's lots of use cases where you see one-to-one already how you could do it more like a recipe. I stop here saying we have an interesting way ahead. We want to connect, of course, in HIBALL, this supercomputer #1 in Europe with JUBILs. We're very far with it. We have already container running from Canada on the JUBIL system. So the next step is just putting it into the CBRAIN, Helmholtz, and soon eBrains and connection and environment. You see some of the funding that should be not missing. You see it's quite academically driven here with the funding. That's quite important to point out, the references. And I think that's all I wanted to leave you on the table here. And now we're looking forward to a very nice tutorial together with hands-on, if you will. Thank you very much.